So hello guys, in today's video we are going to see the master method. Master method is a technique to solve the recurrence relation problem. The recurrence relation problem can also be solved by the back substitution method or recurrence tree method, but in master method it is the shortcut to solve any of the recurrence relation. So let us start the master method. First, the condition to fulfill the master method that it T of n, the recurrence relation should be in this form: a into T of n by b plus f of n, where n should be greater than equals to 1 and it is C for n equals to 1. Now there are basically three cases of master method. So let us look one by one. The first case of the master method, if f of n is big O of n log a base b minus epsilon for some epsilon greater than 0. Here epsilon value should be anything which should be greater than 0. Then we can say that the function having the complexity theta of n log a base b. Here we can understood with the help of an example. Here we have given the function t of n is equal to 4t n by 2 plus n. We can check it is in the form of Tn is equal to a, where a is equals to 4, b is equals to 2, and f of n is equals to n. So let us put the formula and check where it is satisfying the first condition or not. So the first condition we have to check n is big O of n log a base b. In log a base b, we can say it is log 4 base 2, and we know log 4 base 2 is log 2 power 2 base 2, which is 2. So it is 2 minus epsilon. Now we know that epsilon value could be greater than 1 here. So if we put epsilon equals to 1, it could be n is order of n 2 minus 1 equals to 1. Let us check if n is order of n. Yes, it satisfies the condition. Then we can say simply T of n is equals to theta of n log a base b. What is n log a base b? It is n square. So our first answer is T of n is theta of n square. Let us move to the second condition. Now let us move to the second case of the master method. That is, if f of n is theta of n log a base b multiplied with log n to the power k for some k such that k is greater than equals to 0, then T of n is equal to theta of n log a base b multiplied with log n to the power k plus 1. But if k is equals to minus 1, then T of n equals to theta of n log a base b multiplied with log n. Now let us understood this with the following example. First we have to check the case 1. Is it satisfying the case 1? So for satisfying the case 1, we have to check is if f of n is big O of n log a base b minus epsilon. So let us check. Here we know that f of n is equals to n, a is equals to 2 and b is equals to 2. Now f of n is big O of n log a base b means n 2 base log 2 base 2. N log 2 base 2 is nothing but n, that is 1, n power 1 minus epsilon. Here epsilon should be greater than 0. For greater than 0, it is not satisfying the following condition. So we should not take the case 1. Now let us consider the case 2. Is n is theta of log a base b, that is n to the power 1 dot log n base k. So we can simply say that yes, it is satisfying the condition for k is equals to 0. So for k is equals to 0, we have the case A, that is if k is greater than or equals to 0. Here k is equals to 0, so we have to put t of n is equals to theta of n log a base b dot log k plus 1 log n to the power k plus 1. Here n is n log a base b is n dot k is equals to 0. We have like that. So the complexity is n into log 0 plus 1 is 1 and log n. So simply the time complexity is theta of n log n for the condition. Now let us quickly understand the third case of the master method, which says that if f of n is omega of n power log a base b plus epsilon, for epsilon which is greater than 0, and it also satisfies the following condition, that is a into f of n by b should be less than or equals to delta of f of n, then we can say that t of n is theta of f of n. Now here you can check the function. The function does not satisfy the case 1 or case 2. You can see by applying case 1 and case 2, it does not satisfy both. So you have to use the case 3. So what the case 3 is, let us check. If n is omega of n log a, here a is equals to 1 and b is equals to 3, log 1 base 3, okay, plus epsilon. Here yes, we can say that for any value, for a value greater than 0 epsilon, for epsilon it is satisfying the condition. So it satisfies the condition. Now we have to check another condition, that if a dot f of n by b is less than equals to delta of f of n. Here n by b, a is 1, so 1 into n by 3 is less than equals to delta of f of n is n. So here we can say that for delta is equals to 1 by 3, it is satisfying the following condition. So we can say the time complexity is t of n is theta of n only. That is the all about the master method. I hope I have cleared all the three cases. Thank you.